The ocean covers over 70% of Earth's surface and support various ecosystems.
When people talk about climate change and the oceans, they usually think about sea level rise or coral bleaching. These problems are important. However, there is another major problem that receives much less attention. The ocean is slowly losing oxygen. Scientists call this process ocean deoxygenation. Ocean deoxygenation means that the amount of dissolved oxygen in seawater is decreasing over time. Oxygen in seawater is essential for marine life. Fish, crustaceans, and many microorganisms need oxygen to survive. Just like animals on the land need oxygen from the air, marine organisms depend on oxygen that is dissolved in the water. Over the past several decades, scientists have observed a measurable decline in oxygen level in many parts of the world oceans. Studies estimate that the global oceans has already lost about 2% of its total oxygen since the middle of 20th century. Some regions of the oceans now experience extremely low oxygen levels. Scientists call these regions oxygen minimum zones. In this zone, oxygen level becomes so low that many marine organisms cannot survive. These situations raises an important question. Why is the ocean losing oxygen as the climate warms? To answer these questions, we need to understand the physical and biological process that control oxygen in the oceans. Three main mechanisms explain why climate change is causing oxygen loss in the oceans. The first mechanism involves temperature and gas solubility. Warm water holds less oxygen than cold water. This relationship follows a basic physical principle. Gases dissolve more easily in colder liquid. When the temperature of the liquid increases, gas molecules escape more easily from the liquid into the atmosphere. This principle also applies to seawater. When the ocean temperature increases, the ability of seawater to hold the dissolved oxygen decreases. Even small increases in ocean's temperature can reduce the amount of oxygen that the seawater can store. Climate change is warming the surface of the ocean across large areas of the planet. However, temperature is only one part of the problem. The second mechanism involves ocean stratifications. Ocean stratifications occurs when water forms layers that do not mix easily. Under normal conditions, ocean water mixes vertically. Surface water interacts with the atmosphere and absorbs oxygen from the air. Ocean circulations and mixing then transport this oxygen downward into deeper part of the oceans. However, when surface water becomes warmer, it also becomes lighter and less dense. This lighter water stays on top of the colder and denser water below it. This creates a layer structure in the oceans. Scientists call these structural stratifications. Stratification reduces vertical mixing between surface water and deeper water. When mixing becomes weaker, oxygen from the atmosphere cannot travel easily into deeper ozone layer. This limits the supply of oxygen to deeper water. The third mechanism involves biological oxygen consumption. Marine organisms constantly consume oxygen through respirations. Fish, plankton, and many other organisms use oxygen as part of their metabolism. In addition, bacteria break down organic matter that sink from the surface ocean into deeper water. This process is called decomposition. Decomposition also consumes oxygen. Normally, ocean circulation supplies new oxygen to replace the oxygen that organisms consume. However, when stratification reduces mixing, oxygen supply becomes limited while biological consumption continues. Over time, oxygen level decline. These combined processes lead to the expansion of oxygen minimum zone. Oxygen minimum zone are regions where oxygen levels are extremely low. This zone already exists naturally in part of the oceans. However, climate change is causing zones to expand and intensify. As oxygen levels fall, many marine organisms struggle to survive. Some species migrate to other regions, while others cannot adapt to the new conditions. 如果用比较简单的方式解释这个问题，其实可以把海洋想象成一个巨大的呼吸系统。海洋里的氧气并不是固定不变的，海水必须不断循环，才能把氧气从海面带到深海。但是，当气候变暖的时候，海洋会发生几个重要的变化。第一个变化是温度。当海水变暖的时候，它能溶解的氧气会减少。简单来说，冷水可以储存更多氧气，而热水可以储存的氧气比较少。所以，当全球海洋温度上升的时候，海水本身就会自然失去一部分氧气。第二个的变化是海洋分层。当海洋表面的水变得更温暖的时候，这些水会变得比较轻，并且停留在海洋的上层。下面的水比较冷，也比较重，所以两层水就不容易混合在一起。这种现象就像油和水一样，上层和下层很难混合。当这种分层越来越明显的时候，氧气就很难从海面被输送到深海。第三个变化来自海洋生物。海洋里的鱼类、浮游生物和许多微生物都需要氧气来生存。同时，深海里的细菌也会分解从海面沉下来的有机物。在这个过程中，它们会消耗氧气。如果新的氧气没被输送到深海，但是生物仍然在继续消耗氧气，深海的氧气浓度就会越来越低。当氧气下降到某一个程度的时候，就会形成所谓的缺氧区。在这些区域，很多鱼类和海洋生物很难生存。这不仅会影响海洋生态系统，也可能影响全面的渔业资源。Ocean deoxygenation is often described as a silent crisis. Unlike sea level rise or storms, this process happens beneath the surface of the oceans and is difficult to observe directly. However, the consequences can be significant. Oxygen loss threatens marine ecosystem and reduces biodiversity. Expanding oxygen minimum zones may also affect global fishery and food security. The ocean play a critical role in regulating Earth climate and supporting life on our planet. Understanding how climate change affects ocean oxygens is therefore an important part of understanding the broader Earth system. Ocean deoxygenations show how closely connected climate processes are with the biological system in the oceans. As climate change continues, the loss of oxygen in the oceans may become one of the major environmental challenges for marine ecosystems in the future. Understanding this mechanism is therefore important for both environmental science and global sustainability.